Okay, let's get a little practice with distance versus time graphs or position versus time graphs. We have laid out some steps at the beginning of the page that you can read through. My recommendation is to try these on your own and then check our work. So let's look at number one. Number one says a dog walked 5 meters in 5 seconds, stopped for 2 seconds, and then returned in 5 seconds. If we're following our instructions at the top, the first thing we need to look for is the distance and then the time. So if it's going 5 meters in 5 seconds, it's going a total of 5 meters to begin with, right? And it's doing that in 5 seconds. That's segment one. Segment two is right here. It says it stops for 2 seconds. Our distance does not change, but we need to add 2 more seconds to our time right there. And then let's look at our third segment. It says it returned in 5 seconds. So what's happened, the dog has walked 5 meters, it stopped, and now it's returning. So because it's going back to the direction that it came from, we don't need to add more distance to our y-axis, so that will be 0. But we do have to add more time because it says it takes it 5 seconds to do that. So we'll add 5 there. So when we add up our numbers, our total distance will be 5 meters that we need on the y-axis, and our total time will be 12 seconds that we need. So let's go ahead and set that up. I'm going to make my graph a little larger because it's so small on here. So I'm going to say this is 1, 2, 3, 4, and 5 meters. So I only have to go 5. And then I have to go 12 seconds. So I'm going to say 1, 2, 3, 4. And make sure you have your units on your axis or it's wrong. So the next step says we have to put a 0, 0 or a dot at the origin at 0, 0. And then we have to look at our coordinates. The first segment, he goes 5 meters and 5 seconds. So our time is 5, and he's also went 5 meters. So we would put our dot at 5, 5. The second one, he has stopped for 2 seconds, but his distance hasn't changed. So 5 plus 2 seconds is 7 seconds, and we're still at the 5 meters right here. Then it says he returns in 5 seconds. So he's going to go 5 meters in 5 seconds, and he's going back the direction that he came from. So that's going to take us back to the 0, and it takes him 5 seconds. So 5 plus 7 gives us 12. So it would be at 12, 0. And then we need to connect our segments, segment 1, segment 2, and segment 3. And we would have 0, 0. We're going to have 5, 5. Then this will be 7, 5. And it will end at 12, 0. Now let's look at the second one. It says a ball rolled 2 meters per second for 3 seconds, stopped 1 second, and continued rolling 3 more meters in 2 seconds. I'm going to do this one a little bit different, so you can choose whichever way makes sense to you. So I'm going to go ahead and list 0, 0, because I know that's my starting point. And then it says it goes 2 meters per second for 3 seconds. So my next point is going to be at 3 seconds. And what is the distance on that? It's going 2 meters every second, and it's going 3. So 2 times 3 will give me 6 meters. And then it stops for 1 second. So my distance stays at 6. It doesn't change, but my seconds, I have to add 1 to. So 3 plus 1 gives me 4 seconds. Then it continues to roll an additional 3 meters in 3 seconds. It doesn't say it returns or goes back. It continues in the same direction. So I'm going to have to add 3 meters to my distance and then 3 seconds to my time. So if I come and do my distance first, if I add 6 plus 3, that's going to give me 9 meters total. And if I add my time, 4 plus 3, that gives me 7 seconds total. And this gives me my coordinates that I need to plot. So once again, make sure that you look. Our highest x value is 7. and our highest y value is 9. So that means my y-axis is my distance. Make sure you label that as meters. Has to go to 9. So I'm just going to go by 2's. And then I'm going to do my x-axis by 1's. And I'm going to go ahead and put seconds down there so I know. And then I just have to plot my points. It'll be 0, 0. Then it's going to be 3, 6. Then it's going to be 4, 6. And 7, 9. And then we connect them. And there we go. And I like to add my coordinates on there. Just so we know. And that's the second one. I'll do the third one in the same way as the second one real quick for y'all to help you out. So it says a student walked to their class that was 16 meters away in 8 seconds. My starting coordinate is 0, 0, and they're going to go 8 seconds, 16 meters. And then it says they stopped for 3 seconds. So I need to add 8 plus 3. That's my time, is 11, but my distance has not changed. It's at 16. It says they forgot their phone and they went back to their last class. So if you think about it, here's where they started. And now they went 16 meters. They stopped. And now they're fixing to go back to get their phone. And it says they make it back in 4 seconds. So my next coordinate is going to be 11 plus 4, which will give me 15. And they're going back to where they came from, so that's going to be at 0, 15, 0. It says it took them 2 seconds to get their phone, so they're stopped for 2 seconds. So add 2 seconds to your 15 seconds. And their distance has not changed, so it's still going to be a 0. And then it says they're going to turn around, so come back up here with me. I'm right here. It says they're going to turn around and they're going to go back to their last class. Remember, this was 16 meters that they're going back to. So we need to add 17 plus 16, because that's how much time it took them, which will give me 33. And their class was 16 meters away, so we're going back to the 16. So there's our coordinates that we need to graph. It will be 0, 0, 8, 16, 11, 16, 15, 0, 17, 0, and 33, 16. I will go ahead and go by 2's. Make sure you put your units. This is seconds, and this is meters. And I'm going to say 2, 4, 6, 8, 10 meters. And then for my time, I'm going to go by 3's. Is that right? Yep, and we'll stop there. Okay, so my first one here is 0, 0. Here we are, 0, 0. And then we go to 8, 16. I'm just going to take a good guesstimate and figure my 8's about right here. And I'm going to mark that as 8, 16, so I know. And then I go to 11, 16. 15, 0, 17, 0, and then to 33, 16, back to class. So our graph is going to look something like this. 15, 0, 17, 0, and then back up to 33, 16. And that describes the motion. Hopefully this helps.